Good morning, students.
Good morning, ma'am.
Okay, yesterday we have seen the second unit. Try to practice all the exercise and MCQ questions. Okay. So today we'll start the third unit. So third unit, you have the bisectors of the angles are there. So introduction, I have told the how to find, that is what is the procedure to find the angle between the two planes when they are bisecting. Okay, the third unit is bisectors of the angles between two planes and two sides of a plane. Okay, so in that first topic is finding the angle between the two given planes when they are bisecting each other. Okay, so the formula is the two angles will be there, ax plus by plus cz plus d equals to 0. Okay, first one in this is, if two planes are given, ax plus by plus cz plus d equals to 0 and a1x plus b1y plus c1z plus d1 equals to 0. Okay, so the bisectors of the angles between two planes. So the formula is ax plus by plus cz plus d by under root of a square plus b square plus c square equals to plus or minus a1x plus b1y plus c1z plus d1 by under root of a1 square plus b1 square plus c1 square. Okay, so this is the formula to find the bisectors of the angle between the two planes. So whatever the numerator here, plane equation is there, under root of that quotients of xyz square, here also same one. So first thing is, after writing the given two planes in this form, so if any under root of a square plus b square plus c square is there, no any simplification is there, means you simplify these two, then you cross multiply them. After cross multiplying them, first you add them, then next you subtract them. So if you add and if you subtract them, you will get the two equations. Okay, so given two equations are there, and after doing the addition and subtraction, you will get two more equations. That means you will get the four equations. So from the four equations, 1 and 3 and 2 and 4, if you do the simplification of 1 and 3 and 2 and 4 equations, first thing is finding here just the bisectors. After that, the second part is finding the angle between the planes. For finding the angle between the planes, from the four planes, you take any two planes and find the, we know that the formula is cos theta is equals to a1 into a into a1 plus b1 into b into b1 plus c1 into c1 under root of whole square. Already in second and first unit we have seen the angle between the two planes. So applying that formula, you find the cos theta value. If you are getting the cos theta value, if the theta value to know in the question, he will mention that whether the angle between the two planes is an acute angle or the angle between the two planes is a obtuse angle. Okay, in the question it will be mentioned. So for any two cases, that is if you are doing 1 and 3, you may get it as acute or obtuse. Means while doing 1 and 3 or 2 and 4, for one you will get the acute angle, for you another one you will get the obtuse angle. That means if theta is less than 1, you will get the acute angle. If theta value you are getting greater than 1, then you will get the obtuse angle. So the procedure is first finding this one, after that finding the cos theta value. So with the help of the cos theta, if you are not getting, means convert it into sin theta, then you find the tan theta. Tan theta, we know that sin theta by cos theta. If theta value, why? Because in tan theta value, that is 45 tan 45 degrees is one value, no? So from that, with the help of that, you can see whether it is greater than 1 or it is less than 1. Okay, so that is the first concept in the unit 3. Next, after that, you have the two sides of a plane. So one plane equation will be given, and in the question 2 points will be given. Okay, so first you substitute first point in the one plane, whatever the given plane, you will get some value. So if the value is less than 0, if whatever the answer you are getting, it is -1, if you are getting, it is less than 0. So one point you are taking, that is if you think x comma y comma z, you are substituting in one plane, and next another point x1 y1 z1 in the same plane. Only one plane equation will be there. Okay. So if this point you are substituting here and you are getting any negative value which is less than 0, and another point if you are substituting in the same plane and you are getting here +1, if it is greater than 0. Okay, +1 means you are getting it as greater than 0. This is the both are negatives, opposite signs. No, this is positive is there, this is negative is there, and this is positive is there. Means they are opposite sides. The two planes present on the opposite sides. So if you are getting the same sign here, that is -1, then both you are having the same signs. So the two planes lies on the same side. Okay, that is only the main intention. Oh, -1 you will not get, somewhere you may get -2. So here negative sign, but the values will be not same. Only the negative sign, -1 which is less than 0, -2 means the symbol here. It is less than and less than. That means it represents they are on the same side of the plane. If one is greater and another one is less, means they are opposite sides of the plane. So if -1, -3 means it is less than 0, it is less than 0. Then they are on the same side. Okay. So if opposite signs are you're getting, then they are called as opposite sides. If you are getting the same side, then they are called as the same sides of the plane. This is the 5 marks question you will get, and whatever the above one I have told, this is the 10 marks question you will get. So this one, even in the multiple choice also, if they are not asking for the 5 marks question, direct by seeing the substituting the point, you can find whether the two planes they are lying on the opposite side or on the same side of the plane. Okay, this is the second concept we have in this unit. And third one is that is a pair of planes is there. Okay, one plane equation will be there, that is ax square plus by square plus cz square 2fyz plus 2g zx plus 2hxy, ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy equals to 0. Okay, so this represents a pair of planes, combination of two planes. Whenever you do that, you will get this one. This is the equation, means it represents a pair of planes. So whatever the plane is there, pair of planes, it passes through the origin if and only if one condition is there. So if it satisfies that condition, then only this pair of planes satisfies, means it is passing through the origin. So this theorem proof is there in the page number 76 and 77. Okay. So how you are getting the plane, if the pair of planes equation that is given in 76, 77. So almost this is a very lengthy one. So they will not ask for the examination, but the necessary and sufficient condition is there, so that you may get for the examination. So 75 page number 3.4.2 is there. So this you may have chance, or else it is of 2-3 pages are there. Okay. So only depending on this, you will get the problem you will get. So that problem, if you know the formulas, it's enough for solving the problems. So the necessary and sufficient condition here is ABC plus 2FGH minus AF square minus BG square minus CH square equals to 0. Okay. To represent this equation as a pair of planes passing through the origin, if and only if this condition is satisfied. Okay. So this whatever equation is there, this in the question they will mention. So from the question you have to see what are A, B, C, F, G, H values. After finding those values, substitute in this equation. If after substituting these values in the equation, you are getting the value as 0, then the whatever the pair of planes are there, they will pass through the origin. And you have to verify another condition for this one, that is f square is greater than or equals to bc, and g square is greater than or equals to ac, and h square is greater than or equals to ab. Okay, if these two conditions are satisfied, then we'll tell that whatever the pair of planes are there, they are passing through the origin. Okay. So problem will be asked like this, and for this only combination, he will even ask the angle to find out. Okay. So for this one, you have the formula is that cos theta is equals to a plus b plus c by under root of a plus b plus c whole square plus, so angle between them is plus 4 into f square plus g square plus h square minus bc minus ac minus ab. Okay. So this is the formula for, so question will be combination of this one. Show that the given pair of planes satisfy the given condition and find the angle between them is first, after taking the values from the given problem, you have to substitute in this one. If you are getting the value 0, it represents a pair of planes. So after that, you have to verify compulsory these three conditions. That is f square is greater than or equals to bc, g square greater than or equals to ac, h square greater than or equals to ab. If these two conditions satisfied, then they represents a pair of planes passing through the origin. After that, to find the angle between the pair of planes, the formula is cos theta equals to a plus b plus c divided by under root of a plus b plus c whole square plus 4 into f square plus g square plus h square minus bc, ac and ab. Okay, so all values if you substitute, you will get the cos theta value. So for this only, in this only, if you want to find direct tan theta value, for tan theta you have the formula. So here tan theta is equals to 2 into just inverse of that one, you will get x square plus g square plus h square minus bc minus ab minus ac by a plus b plus c. Okay. So that is whatever it is there, inverse of that one, a plus b plus c you will get in the denominator, and this means cos theta is equals to this value. We need to find the sin theta value. So after getting the sin theta, if tan theta is equals to sin theta by cos theta, so denominator whatever will be there, that will be interchanged. So tan theta, so even you can find the angle directly tan theta or else cos theta. Anything if you find, you will get the same angle. Okay. So tan theta formula is this one and cos theta is this one. So first part this one, second part is two sides, and third one is finding the pair of planes, and fourth one is finding the area of the triangle. So area of the triangle when three vertices are given. So you have the formula for this one for finding the area of the triangle when three vertices are given. And next fifth concept we have is the finding the volume of tetrahedron. Okay, so these are the topics, 5 topics you have in third unit. So in this 10 marks question is first one, bisectors of the angles, and next you have cos theta, whatever the angle you are finding, you may get they may ask for 5 or 10 marks. Okay, so 5 marks means pair of planes they will ask. If angle is also asked means you may have chance of getting 10 marks question. Next fourth one we have that is two sides of a plane is there, no, that is 5 marks question. And fourth one, area of triangle is also 5 marks question, and fifth one, volume of the tetrahedron. For this also you have formulas, and for this also you have the formula is there. So while solving the problem, we'll see that one. So these are the 5 topics we are going to cover in unit 3. So first we'll see one problem on bisectors of the angle between the planes. So if any sentences in the solutions are there, try to write from your textbook. So if you write all the sentences and those all, it will take more time. Okay. So first question is find the bisector of the obtuse angle between the planes 3x plus 4y minus 5z plus 1 equals to 0, and 5x plus 12y minus 13z equals to 0. Okay, these are the two given planes. So I've said you're not able to get the question. No? Okay, now you are able to see the question. It is the find the bisector of the obtuse angle between the planes. Okay, so is mentioned in the question itself that what is, for which planes you are getting the obtuse angle. Okay, so in the solution you write the given planes are so first one put it as equation 1, 4y minus 5z plus 1 equals to 0, and next one is 5x plus 12y minus 13z equals to 0. Okay, so the bisectors of the angle you have now the equations of planes bisecting the angle between them. Okay, it is equals to, that is whatever the formula is there, 3x plus 4y minus 5z plus 1 by under root of the coefficients of x, y, z, that is 3 square plus 4 square plus minus 5 square. It is equals to plus or minus 5x plus 12y minus 13z by under root of 5 square plus 12 square minus 13 whole square. Okay, so here this is 9, this is 16, and this is plus 25. So 25 plus 25 means you will get it as 50. 50 you can write it as, that is 5 root 2. Okay, and here you will get it as 25, and 12 whole square means you will get 144, and 13 whole square is 169. So 169 plus this is also 169. Okay, so if you add both of them, so that you can write it as 13 root 2. So whatever, if you get on adding this one, why? Because 13 is there, no? So you can write it, take out 13 outside, that is 13 root 2. So this is 3x plus 4y minus 5z plus 1 by 5 root 2. So it is equals to plus or minus 5x plus 12y minus 13z by 13 root 2. So you cancel out the root 2 on both sides. Now you do the cross multiplication, 5 with this one and 13 with this one. Okay, so you will get that as 39x plus 52y minus 65z plus 13 equals to plus or minus 25x plus 60y minus 65z. Okay, so when you do the cross multiplication of this, you will get this one. So next thing, what you have to do, first you have to add these two equations, so you'll get one equation, and when you do the subtraction of these two equations, you will get another equation. So those are 3 and 4 equations. Addition means here plus sign, when you take out this on the left hand side, all you will get the negative one, and when you take out the negative sign, you will get all the positive values. Okay, on adding and subtracting these two equations, you will get two more plane equations. So the equations are here 14x minus 8y plus 13 equals to 0. This is the third equation. Okay, next one is 64x plus 112y minus 130z plus 13 equals to 0. So this on adding you will get, and this on subtraction you will get. So you are getting 3 and 4. So from 1 and 3 and also 2 and 4. So if you do, if you find the angle between those planes, you have to see for which plane equation. First and second you should not consider. Whatever the bisecting planes you are getting with the help of this one, third and fourth. In third and fourth, so which plane is making the obtuse angle, you have to verify that. So if 1 and 3 you are getting the obtuse angle, then this whatever the plane equation is there, this plane equation is making the obtuse angle. If you are doing 2 and 4, Then if you are getting any acute angle, then this whatever plane is there, this plane is making the acute angle. Okay. So no need of finding another one. So if you find 1 and 3, if you are getting the obtuse angle, just you leave that one. So if in the question is mentioning both the angles, that means find the planes for which obtuse angle is forming and also acute angle is forming, means then you do both of them. Okay. So now if theta is angle between one and 3, so if theta is the angle between so in cos theta you substitute the values. So cos theta is equals to plus or minus. So what is the first equation? First equation is 3x plus 4y minus 5z plus 1 equals to 0. Okay. So 1 and 3 means 3 into 14. Next we have minus is there, no, minus 8 into 4. Next we have constant value. Okay, so only these two values you will get. Here z value is not there. What is the formula? Only a into a1 plus b into b1 plus c into c1 only. So your constants will not get. So 14 into 3. Next you will have plus minus 8 into 4. So z value is here 0. So 5 into 0 means you will get that value 0. So divided by under root of this 14 whole square plus minus 8 whole square. Here only two quotients are there. Next one we have, that is 3 square whole square plus 4 whole square plus minus 5 whole square. So just now we got that value, no? This is 5 root 2 you will get. Why? Because 50 you will get root 50, and here 14 whole square and also 8 whole square. If you do, the value is here 14 into 13. So it is 42. 42 minus 32. So the value is here 10 divided by, this is 5 root 2 and it is 2 root 65 you are getting. And this is 5 root 2. So this one 14 whole square. So 260 you will get this one. Root 260. Okay, this value is 2 root of 260. When you do with the help of the LCM, you will get it as 2 root of 65. That is, if you multiply with 65 into 4, you will get the same one. 6 4 are 24, 260. Okay, you know, I think so how to find this one. So whenever you add these two numbers, you are getting root 260. With the help of finding the LCM, you will get it as 2 root of 65. Okay, now you can here cancel out this 2 5 times and this 5 will get cancelled. So you will get 1 by 130. Okay, 65 into 2 times. Both the roots you are multiplying, so it is root of 130. So this is cos theta value. So if you want, with the help of the calculator, you can find what is the root 130 value, and then you divide it. That is 1 divided by that value. If you are getting less than 1, then it is the acute angle. If you are getting greater than 1, it is the obtuse angle. Or else you can convert it into sin theta. That is sin theta is equals to root of 1 minus cos square theta. Okay. So it is equals to root of 1 minus, our cos theta value is this one. So we will get 1 by 130. So root will get cancelled. So it is 130 means it is root of 130 minus 1 is 129 by 130. Okay. So this is our sin theta value. Next you can convert into tan theta. Tan theta is sin theta by cos theta. Okay. So here sin theta what we got? Root 129 by root 130. So cos theta means just you interchange that one. That is root 130 by 1. So both will get cancelled. It is root 129. And root 129 means 11 whole square is 121. So you will get it as some 11 point something. So this value is greater than 1. Okay. So the angle here, with what angle we have done the cos theta value, we have found this one. So the plane equation is 14x minus 8y plus 13 equals to 0 is the plane which makes the accused angle. Okay. So here you can write, therefore, the plane 14x minus 8y plus 13 equals to 0 obtuse angle. So whatever you have the sentence in your textbook, try to write that one. Is the plane 4 bisects is there. Bisects the accused angle. Okay. Hence the plane, whatever 3. If you see, if you want, after the completion of your class, you try to find what 2 and 4. You will get the acute angle for that one. Okay. So same procedure you can follow. So just to know in one given problem only, we can find the obtuse angle and also acute angle. Compulsory, one will be acute and another will be obtuse angle. So if 2 angles are mentioned in the question, then same procedure you follow for the another equation also. Okay. So this is how to find the bisectors of the angle when 2 planes are given. Here you can write that is theta is greater than 45 degrees. So therefore the plane bisects the acute angle. Okay, this is the procedure. So after that we have to find the 2 sides of a plane. So you have the check your progress, you have problems are there on bisector of the acute angle. Compulsory, try to follow the example problems, practice them. You may get the questions from the examples, or else check your progress, or else you may get from the MEQ questions, that is a model examination questions. Whatever the problem I have told, that is from the MEQ questions. So check your progress means the solution you will have in your textbook. So I am not going into that. Whatever the MEQ questions are given, last page number. So from that I have told the problem. This is the first problem, and second and third and okay, two more problems are there in your textbook. So example problems and also check your progress and these 2 other. So try to solve those problems. The procedure is the same one. Okay. So after that, next we have 2 sides of a plane. So this you are not having in your check your progress. Just whatever the example problems are there, in that only you are having. So here show that the points 2, 3, 5 and 0, 4, minus 7 lie on the opposite sides of the plane. Okay, in the question itself it is mentioned that they lie on the opposite sides of the plane. That means you have to get one less than 0 and another one greater than 0. So these problems you are not having in the MEQ questions, model examination questions. Only check your progress are there and examples are there. So 4 problems are there. So try to practice them. Show that the points 2, 3, 5 and 0, 4, minus 7 lie on the opposite sides of the plane. So here the plane equation is x plus 2y plus 2z minus 9 equals to 0. Okay. So first you write the given plane is x plus 2y plus 2z minus 9 equals to 0 and put it as equation 1. Okay. So next the point here the given is the point 2, 3, 5 lies on the given plane. Lies on the given plane 1. So that is in place of x, y, z, you substitute this one. So you will get it as 2 into 3 plus 2 into 5 minus 9. Okay. So this is equals to 2 plus 3 2s are 6 plus 2 5s are 10 minus 9. So it is 6 plus 2, 8. Means you will get the positive. That is, it is equals to 18 minus 9. So 9 which is greater than 0. Okay. Next, the point 0, 4, minus 7 lies on plane 1. So you'll get that is first one is 0 means this value is 0 plus 2 into 4 plus 2 into minus 7 plus 9. Minus 9 equals to 2 4s are 8, 7 2s are 14 minus 9. So it is minus 15 you are getting. So that is 8 minus 9 is minus 1 you will get 14. Minus 14 minus 1 is minus 15 which is less than 0. So you are getting the opposite signs here. So therefore the points lie on the opposite sides of the plane. So here you can write therefore the given plane therefore the given points lie on the opposite sides of the plane. Okay. So if you are getting here less than 0 and less than 0, then you can write the given points lie on the same side of the plane. So this is a simple procedure. Just whatever the 2 points are given, you have to substitute the points in the plane equation. And if you find the value of that one, if you are getting the same signs, if both are negative, then same sides. If one is positive and another one is a negative, then you will get opposite sides. Okay. So in some case you may greater than, and in some cases you will get that is less than, and in some case greater than, less than. Okay. So this is the procedure to find the 2 sides of a plane. Next we have pair of planes. So for pair of planes, so the problem will be x square. Show that the equation 2x square minus 6y square minus 12z square plus 18yz plus 2zx plus xy equals to 0 represents a pair of planes. Also find angle between them. Okay, the question will be like this. So first you compare the given whatever the equation is there with the help of the that is given equation is 2x square minus 6y square minus 12z square plus 18yz plus 2zx plus xy equals to 0. You put it as equation 1. Compare 1 with, so what is the equation of that one? Ax square plus by square plus cz square 2fyz 2xz plus 2hxy equals to 0. Okay, when you compare with this equation, you will get a value where a equals to 2 and b equals to minus 6, c equals to minus 12, and here f value 2f equals to 18 means f value equals to 9. Next to 2g equals to 2 means g value will get as 1. And here 2h equals to 1. Okay, 2h equals to 1 means h equals to 1 by 2. So h is 1 by 2. Okay. So this whatever you are getting the values. So another equation is there, no, ABC plus. So in that equation, if you substitute that, you have to get the value as 0. If you are getting the value as 0, then it satisfies the pair of planes. Okay. And to represent pair of planes, to represent a pair of planes, we require, okay, so the formula is ABC plus 2F GH minus AF square minus BG square minus CH square equal, that is you have to show it as equal to 0. Okay. So whatever this one is there, if you are unable to remember this one, that is ABC plus 2FGH minus AF square minus BG square minus CH square. This you can remember with the help of the determinant. Okay. So here whatever ABC are there, those are the diagonals you will have. Next you will have the H here, and this is H, and this is here G, and this is here G, this is F, and this is F. So this, if you equate it to 0, that means you have to find the determinant of these values. So whatever this equation is there, with the help of this determinant you will get. So A, B, C. So these are A, B, C. After that H and H, G and G, and F and F. If you find the determinant of this formula you will get. Okay. So this you have in your textbook. If you are unable to remember this formula, with the help of this determinant you can remember. So now substitute the values in this one. So A, B, C. A is 2 minus 6 and minus 12. After that plus 2 into, what is F value? 9. 9 into 1 into 1 by 2. Okay. GH minus, right here, you are able to see. So it is equals to 2 into minus 6 into minus 12 plus 2 into 9 into 1 into 1 by 2 minus A value is 2. 2 into F square means 9 whole square is 81. After that minus B. So minus into minus is plus 6 into G square. G square is 1. After that minus C. This is plus, you will get plus 12 into 1 by 4. So this is 3 times. And here minus into minus plus. So 6 2s are 12. 12 into 12 means 144. Plus this 2 will get cancelled. So plus 9 minus this is 162. 6 plus 3 is 9. Okay. 9 9 18. 18 plus 144 means 162. You will get 162 plus 162 and minus 162 means you will get it as 0. Okay. So whatever from the given equation, if you substitute the values, you are getting the answer, means it is satisfying the condition of this one. So what the given plane represents a pair of planes. So this is the first part he has asked. And another one is we have to see F square is greater than or equals to BC. So the 3 conditions are there, no? The 3 conditions also it has to satisfy. Okay. So for that one also F square. So what is F square value? F square is, that is 81. And what is BC? B value is minus 6 and C value is minus 12. So 16 into 2, how much you will get? 72. Minus into minus is plus. So this value is 72. And we can tell this F square is greater than BC. Okay. So 81, some cases you may get equal to also, both same. So F square is greater than BC. First condition is satisfied. Next to G square. What is G square? G is 1. G square is for AC. What is AC? A is 2 and C is minus 12. It is equals to minus 24. So 1, no, G square is 1. So implies G square is greater than AC. Okay. Next one, H square. H square is 1 by 4. And AB, what is AB? 2 into minus 6. It is minus 12. So 1 by 4 means you will get 0.25 something. But here AB value is negative value. So therefore H square is greater than AB. So even these three conditions are satisfied. So first condition is this one. So after that, if it is equals to 0, when we have to check the other three conditions. If three conditions are satisfied, then the given plane represents the pair of planes. So here you write, therefore the given equation represents a pair of planes. So this is the first part we have completed. Now second part is we have to find the angle. If theta is the angle between the pair of planes, then cos theta is equals to plus or minus a plus b plus c. Okay, I hope so you remember the formula. That is by a plus b plus c whole square plus 4 into s square plus g square plus h square minus ab minus bc minus ac. Okay, so this is the formula. So in the examination, try to write the formulas here. Okay, in this if you substitute, a value is 2, b value is minus 6 and c value is minus 12 by that is 2 minus 6 minus 12 whole square plus 4 into 9 1. So in the down I am writing this one, that is 2 minus 6 minus 12 by under root of 2 minus 6 minus 12 whole square plus 4 into, what is f? F value is 9, that is 81 plus 1 plus 1 by 4 minus AB. So A is 2, B is minus 6, C is minus 12. So A into B means minus 12, minus of minus means plus 12. Next minus BC, these two will become plus, and after that minus 72. Next minus AC, A and C, minus of minus is plus, that is 12 to the 24. Okay, so when you simplify this one in the numerator, that is you will get the negative value. Is minus 16 by 256 plus 185. This is the 256 you will get, that is if you will 10 minus 10 minus 6 means minus 16, minus 16 whole square is 256, this one. Okay, next this part you will get it as 185. Okay, so after doing the simplification, this whole part you will get as 185. So when you add both of them, you will get as 441, that is root of 441. So it is equals to minus 16 by 21. Okay, so minus 16 by 21. So we need to find the value, no? That is theta is equals to, if you keep in the cos theta, then the value is same. Okay, So if you convert it into tan theta, we have tan theta formula, no? Tan theta is equal to 2 under root of x square plus z square. Even here you can substitute and you can see here. Okay. So here 2 x square plus z square plus h square means this value will get this is 185 into root 185 by in the denominator what you will get minus 16 means 2 8 times root 185 by 16. So a plus b plus c means 2 minus 16 you will get. Okay, root 85. So by 4 will be there, no, here. By 4 means actually here you will get 2. So both these 2 will get cancelled. So this is root 85 by. So we can take this as positive value. Okay, root 185 by 16. See, this part is numerator. If you add, you will get 185 by 4. Under root is there, no? So this 4 you will get as 2. So this 2 and this both 2 will get cancelled. So root 185 by 16. Okay. So theta equals to, if it is tan inverse, it is root 185 by 16. So if here cos inverse means here also theta is equals to cos inverse 16 by 21. Okay. So either this angle you can keep or this one. Okay. So why? Because in the textbooks they will give the almost they'll consider the tan theta. So that's why we are using the tan theta. So while if you substitute here, whatever the answer you are getting, just you write as theta equals to cos inverse of that one. Here negative value will go to positive because why? Because cos of minus theta is positive value. So you are taking theta equals to cos inverse of 16 by 21. So here angle also tan theta is equals to, here in the denominator you are getting negative value. So you take consider it as a positive value, root of 185 by 16. So if you are unable to remember the tan theta formula, before problem we have done, no, under root of 1 minus cos square theta. With the help of that sin theta you convert, and if you divide cos theta and sin theta you will get the tan theta. Okay. So if you do any procedure you will get the same answer. So this is about finding the pair of planes. Okay. So on based on this pair of planes, you have many example problems are there, and also you have check your progress, it is there, and even MEQ questions are also there. So if you see page number 94, so obtain the necessary and sufficient condition that a homogeneous second degree equation represents a two planes means finding the condition is there, no? This formula whatever ABC plus FGH, that is G into 2G YZ plus 2FYZ plus 2GXZ plus 2HXY equals to 0, and H square is greater than or equals to AB, F square is greater than or equals to BC, G square is greater than equals to AB. That whatever the procedure is there, that is only the necessary and sufficient condition. Okay. So this, for this proof you have in your textbook. So fifth question whatever is there, I have told that one, and after that only one problem, and in the check your progress one more problem is there, and example one problem is there. So try to practice these all problems. Next we have the concept of finding the area of the triangle. Okay. So for finding the area of the triangle, when three vertices are given. So first write the formulas here. So before that, you have the concept of orthogonal projection on a plane. So in that only you have the concept of area of the triangles. 82 page number you have orthogonal projection on a plane. So you have the definition here. The foot of the perpendicular drawn from any point P to the given plane pi is called the orthogonal projection of the point P on the plane. So like this, if any from point P you are drawing a foot, this is called as a foot of the perpendicular on any plane equation pi. This is called the projection of point P on the plane pi. Plane pi, point P, from this you are getting the perpendicular, this one. This is called as a foot of the perpendicular of that, and this is called as a orthogonal projection on a plane. Okay, after that, see 83 page number, you have theorem is there. How to find the area of the triangle when three vertices are given. That is the vertices you are taking for that. Each one means three vertices will be given. With the help of the three vertices, you have to find the three areas. That is AX, AY, AZ. Okay, AX, AY, AZ be the areas of the projection of an area A on the three coordinate planes. Then A square equals to AX square plus AY square plus AZ square. Okay, so this is the theorem you have. So no need of finding the proof of the theorem. Only the problem is important. If AZ so are the three areas we have. So to find the area, first one AX. So it is equals to 1 by 2. You will get Y2, Y3, Y4, Z2, Z3, Z4, 1, 1, 1. Okay, this is the formula we have. Next, AY equals to 1 by 2, X2, X3, X4, Z2, Z3, Z4, 1, 1, 1. Okay, next AZ equals to X2, X3, X4, Y2, Y3, Y4, 1, 1, 1. Okay, so if the vertices are given as X2, Y2, Z2, X3, Y3, Z3, and X4, Y4, Z4. Okay, so if the vertices are given like this, so if for three vertices, these are the areas we are finding with respect to of X, with respect to of Y, and with respect to of Z here. So try to remember the formulas. The formulas are nothing. If you are finding with respect to of X, here X will be not there, X values. Only YZ, this one, whatever it is there on the third column, this is same for all the three formulas. Okay, so only here it represents, if it is X means YZ, Y means XZ, Z means XY. So whatever this with respect of which variable we are finding, that values will be not there in the formula. Okay, so if you remember these three formulas, with the help of the given 3 points, you can find the areas of AX, AY, AZ. If you substitute these values in the formula, it is there, no, that is A equals to under root of AX square plus AY square, then AZ square, then we'll get the area of the value A. Okay, so this is the procedure to find the area of the triangle whose vertices are the points given. Okay, so we have the question here. Find the area of the triangle whose vertices are. Find the area of the triangle whose vertices are. So it is, you have in, check your progress, it is there 4 3 minus 2 3 0 1, and we have next one is 2 minus 1 3. Okay, these are the three vertices you have. So with the help of these three vertices, you have to substitute them in the given formulas. So some sentences are there in your textbook to solve the problem. That is first. So let A be the required area of the triangle. A be the required area of the triangle, and AX, AY. So in the examination compulsory, whatever the theory part sentences are there, try to write all the, be the area of projection projections of area A on X, Y, Z. ZX planes. Okay. So the sentence after writing that, the vertices of the projection of a triangle on XY plane. Okay. So whenever you are taking the vertices of the projection of triangle on XY plane, you will get this value equal to 0. Okay. So whenever you are taking the the vertices of the projection of triangle on XY plane means you will get the y value as 0. Okay. Or in the given vertices, you write the z value as 0. That is, you will get it as 4 3 0. Next one 3 0 0. Next, and 2 minus 1 0. Okay. So for this one, show so that, so we have, this is AZ is equals to 1 by 2. So AZ means we will get x and y values. So what are x values? 4 3 2. 4 3 2. Next y values are 3 0 minus 1. 3 0 minus 1, and last 1 1 1. Okay. So for this you find the determinant 1 by 2. For one, just I am telling the determinant how to find. For others, we will write the direct one. That is 4 into, this is 0, minus into minus is plus 1. After that, this value is minus 3. If you take out this column and this row, 3 into 1 is 3, minus 2. Next, plus 1 into 3 into minus 3, and this value is 0. That is minus 3. This you will get 1 by 2 into, this is 4. 3 minus 2 is 1. That is minus 3 minus 3. So minus 6, 4 means minus 2. Minus 2 divided by 2 means you will get minus 1. Okay. So here the AZ value area is minus 1. Similarly, we will find with the help of so you write here the point here, the vertices of the projection of triangle on YZ plane. YZ plane means here you will get x equals to 0, or x equals to 0 means it is 0, 3, minus 2, So plus 2, no? Okay. Next you will get 0, 0, and last value is -1. Next, third one is 0, -1. What is the point? 4, 3, -1. Next we have 4, 3, 2. 3, 0, -1. What we have the point? 4, 3, -2. Next 3, 0, 3, 0, 1. Next 2, -1, 3. Okay, these are the points. So here x value is 0, no? So 3 minus 2. This is 0, this is 0. Here 1. Next we have 0, -1, 3. That is, in place of x, we are substituting the zeros. So what you will get? So ax equals to, so we are finding for x, okay? So that ax equals to 1 by 2 of, so x means you will not have the x, whatever the points are there. So y and z. So here what are, this is x, no? So next we have y. Y is 3, 0, -1, and z are -2, 1, 3, 1, 1, 1. Okay. So this ax value you will get it as -3 by 2. Okay. You do the simplification after that. Next. So same one you write the projection, the vertices of the projection of triangle XZ. Okay. So XZ means here y equals to 0. So y equals to 0 means this value is 0. So 4, 0, -2. Next 3, already 0 is there. So no need of writing again. 3, 0, 1. Next 2, 0, 3. So this is the point. So that AY equals to, AY means x will be there, but here y will be not there, y values. So what are the z values? Z values are -2, 1, 3. Okay. -2, 1, 3, 4, 3, 1, 1. So this answer you will get it as 1 by 2. Okay. So after finding the determinant, you check. So this is the 1 by 2. So last one, the area of the given triangle is, the area of the given triangle is, so what is that? A equals to under root of ax whole square. If you want, you can write the formula ax ay square plus az square. Okay. So here a is equals to under root of, what is our ax? First what we got? -1, no? First ax. So ax is -3 by 2 plus 1 by 2. And az we got -1 whole square. Okay. So this is 3, 9 by 4 plus 1 by 4 plus 1. Now this is 9 plus 1 plus 4 by 4. So 9, 10, 14. So root 14 by 2. So the area of the triangle is root 14 by 2. So here, this is the procedure of finding the area of the triangle when 3 vertices are given. So just here, the projections why we are writing means for the area we are finding with respect of y, no? So in that case, whatever the y values are there, they will become the 0. So here, just the sentence, you remember this one. The y values we are not writing here. So the y values are 0 here. We are writing x value and z value. Whenever the case it is yz means x values are 0 here. So we are writing only y and z. And here the whatever the constant values are there, they are 1, 1, 1 we are taking. So this is the formula we have for finding the area of the triangle when 3 vertices are given. So just substitute the values in that one, and at last you find the area of the given triangle. Okay. So it's, some problems you have on check your progress, and also this I have question told from the MEQ question. So in MEQ no other question is there, only example problem is there, and another one is check your progress problem is there. So try to practice them. Okay. Next, after the area of the triangle, last concept we have in this is the volume of the tetrahedron we have. If you see page number 84. So page number 84, formula is there for this one. So that is how to find the volume of the tetrahedron when, if it is a tetrahedron, which will have the 4 vertices will be there. That is x1, y1, z1, x2, y2, z2, x3, y3, z3, and x4, y4, z4. Okay. So 3 means we have this formula. So same similarly like this only, you have the formula for finding the volume of the tetrahedron. So all the procedure is given, how you are getting that formula. Okay. So that you have on page number 84 and 85 and even 86. So 86 last, whatever you are getting the formula, that is only called as a volume of the tetrahedron. So even the diagram is given in your textbook, how the tetrahedron will be there. And what are the vertices mentioned there?
We should practice the proof also, ma'am.
Yes, ma'am.
We should practice the proof for that volume of tetrahedron, ma'am.
So you may have chance, but I think so they may not give, but just you verify once.
Yes,
so nothing is there here, volume of the tetrahedron, whatever the diagram is there, A, B, C, D. So all coordinates it is given, determinants is there, no?
Yes, ma'am.
Only 4, 5 steps are there. Okay.
Yes,
so just practice once, you may have chance, but compulsory only problem will be asked, but we can't guess, no. The examiner who are giving the questions, they may think that to give the question. Why? Because 10 marks question means in this only bisectors is there. So if you get the bisectors 10 marks question means well and good. If not, you are not getting means you may have the question you have in the MEQ question C. So actually question is not there in your textbook, only obtain the volume of the tetrahedron is there, and find the volume of the tetrahedron formed by the planes is there. See question 7, 8, 9, and even 10th question, 11th question. These all are of tetrahedron only. After 11th, you have 15th question. 15th question is also of volume of tetrahedron. Okay. So just to, if you get means, try to practice that one. If not, you practice only the problems. Okay.
yes,
so from direct formula, we are doing the problem here. Actually, whatever the formula is given, it is only for the points. Vertices are given, no, 4 vertices are given. Then
yes,
we have the formula is, that is volume of tetrahedron equals to that is V is equals to x1, y1, z1, 1, x2, y2, z2, 1, x3, y3, z3, 1, x4, y4, z4, 1. Okay. So if you find like this 1/6 of the determinant of this one, then whatever the answer you are getting, that is called as a volume of the tetrahedron when 4 vertices are given. Okay.
yes,
so another question, if you'll see in the page number 94, you have to
formed
find
by
the
the
volume of the
planes.
tetrahedron when plane equations are given. Okay. So 4
first
plane
we should
equations
find
are
the
given.
coordinates, ma'am.
What, ma'am?
First we should find the coordinates from the equation of the plane.
No, we can't find the coordinates from this one. See, question number 11 you have a 95 page number.
Yes, ma'am.
Okay. So here we have the show that the volume of the tetrahedron formed by the planes, 4 planes are given.
Yes, ma'am.
Okay. The formula is given that it is 2p
cubed by
divided by
3 LMN.
3 LMN. Okay. So
yes,
actually this is the formula to find the volume of the tetrahedron when plane
Formed by the
equations are given.
planes. Yes, ma'am.
Okay, so actually this whatever it is there, given formula is there, and show that it is there, no. So direct question proof you are not having in your textbook. You have some other proof here. If you'll see page number 91, it is given that delta into 6 into volume of tetrahedron equals to K1, K2, K3, K4 equals to delta to the power of 4. It is there, no?
Yes, ma'am.
Actually, this is the proof you have in your textbook. But here in the whatever MEQ questions are there, in that whatever procedure is given for finding the volume of tetrahedron when 4 plane equations are given. Okay. So this whatever proof is there, I will tell that one. So from that procedure, actually here if you see the plane equations are in the form of my plus nz, nz
Yes,
plus
ma'am.
lx,
Sure.
and lx plus my. Okay, one you are not having, that is in one you are not having L value, in another one you are not having M value, and
value.
another one you are not having N value. Okay, so if you compare that one with the main general, you have no normal
Yes,
form of
ma'am.
the plane equation. What is the normal form of the plane equation? Lx plus my plus nz
Plus
equals
NZ
to p
equals-
is there.
Yes,
Okay,
ma'am.
so when you come, if you see in the question also, see the question number 8. So z plus y is there. Not the question 8 here. All the coordinates are 1 1 are there. Okay, coefficients. If you see the question 15, see
Yes,
2x
ma'am.
plus 3y.
Yes, ma'am.
After that 2x plus 3y. Next we have 3y
3y
plus
plus
z.
Z.
Okay. After that 2x plus z. Okay. So
Yes,
first, what is the plane equation? 2x plus 3y plus z. That means L value is 2 here.
2,
M
M
value is 3.
3 and N value,
N value
is
is 1. So we got the LMN values. And what is the P value? P value is
6.
6.
6.
So if you substitute that values in this formula, directly you will get the volume of the tetrahedron. Okay.
Yes, ma'am.
So actually that is a direct answer we are getting.
So
but the
it may
question
come
be
for
asked
5
for
marks.
5 marks.
Yes.
So for that purpose, you have to find the other procedure. With the help of that, means we have to find the coordinates of that one, and you have to substitute in the formula. Only 3 coordinates you will get. So only this part you will have the formula 1 by 6 of this one x1, y1, z1 values we will get as 0, 0, 0. Okay. So
Yes,
if we have time today, we'll see that procedure. First, we'll find the volume of the tetrahedron when 4 vertices are given. Okay.
Yes.
So directly in the formula, we have to substitute that one. So if you see this one, last 9th question. Okay. Find the volume of the tetrahedron. Formed by the points. So here the points are 1, 1, 3. Next we have 4, 3, 2. Next 5, 2, 7. And last one is 6, 4, 8. Okay. So substitute in them. So if any points are there, you write just the volume of tetrahedron B equals to so 1 by 6 of these values. So 1, 1, 3, 1, 4, 3, 2, 1, 5, 2, 7, 1. Next is 6, 4, 8, 1. Okay. So for this one, you make this whatever column is there, last 1, 2, 3, 4th column. C4 is there, no? So you make this 4th column C2, C3, C4 values. You make them as, that is last value of C2, C4, and here whatever the coordinates are there, you make them that 1 as 0. Okay. So this you can do with the help of R2. We can do, no? That is R2.
R1 is equal
R2 minus R1. Next R3,
R3
is
R3 minus
R1. R4 is R4 minus R1.
R1.
Okay, so it is equals to 1 by 6. First one you keep like that only 1, 1, 3, 1. Next to okay. 4 minus 1 means 3. 3 minus 1 is 2. 2 minus 3 is minus 1. 1 minus 1 is 0. 5 minus 1 is 4. 2 minus 1 is 1. 7 minus 3 is 4. 1 minus 1 is 0. Next 6 minus 1 is 5. 4 minus 1 is 3. 8 minus 3 is 5. 1 minus 1 is 0. Okay. Now, so in the determinant form, in the matrices, we have that when this whatever the column it is has become the 0, we can eliminate this column and this row. Okay. So we have the rule is there. So according to that, this whatever fourth column and first row we are eliminating when these all values are 0. Okay. So the remaining one is only 3, 2, minus 1, 4, 1, 4, next 5, 3, 5. Okay. So if we want here, we can say follow the procedure. That is, if you make these two values as 0, then we can eliminate this row and this column. Only 2 by 2 determinant will be there. Then easily if you cross multiply those two, then you will get the answer. Okay. So here to make this value and this value as 0, we need R2. You are able to see, no? So R2 is only this value you have to check. That is R2 plus 4 into R1. Next R3 is R3 plus 5 into R1. Okay. So only last column values. So now V is equals to 1 by 6. So 3, 2, minus 1, you keep like that only. 4 here plus 4 means it is 12. 12 plus 4 means you will get it as 16 here. This 4 2s are 8. 8 plus 1 is 9. Next here minus 4 plus 4 is 0. In the denominator, this is 5 3s are 15. 15 plus 5 is 20. Next 5 2s are 10. 10 plus 3 means 13. Okay. Next 5 minus 5 is 0. Now we can eliminate this column and this row. Okay. So you will get it as 1 by 6, 16, 9, 20 and 30. Now if you do the cross multiplication, you will get the determinant. No? So that is 1 by 6 into 16 into 13 minus 20 into 9. Okay. This is 1 by 6. So for any given problem, you can follow the same procedure for finding the volume of tetrahedron. Going on decreasing the, that is order of the matrices. From 4 by 4, we have converted into 3 by 3. From 3 by 3, we have converted into 2 by 2. So 2 by 2, when you do the cross multiplication, easily you will get the answer. Okay. So that's why we are decreasing the here order. From 3, we have converted to, from 4 to 3, 3 to 2. Okay. So here you will get it as 1 by 6 into 208 minus 180. So it is 28 by 6 you will get. So 14 by 3 is the volume of the tetrahedron. Okay. So like this you can solve the problems. So with the vertices we have. So here 11th question we have now, show that the volume of the tetrahedron formed by the planes. So the given planes are here. So we'll see the proof of this one. It is the 11th question. Show that the volume of the tetrahedron formed by the planes the planes are my plus, next nz plus, next we have lx plus and Lx plus my plus nz equals to p is 2 p cube by plmn. Okay, so this we have to show. So for this one proof, so the given planes are, what are the given planes you write? So first one is my plus nz equals to 0. You put it as 1. Here only I am writing. So nz plus lx equals to 0. Next, lx plus my. So this is second equation. This is the third equation. And fourth one is lx plus my plus nz equals to p. This is the fourth one. Okay. So if you solve 1, 2, and 3, so you will get the x, y, z values as 0, no? So why? Because my plus nz equals to 0 means you will get my value equals to minus nz. And from this, if you take any of them two, you will get nz and nz will get cancelled. Lx plus my. Lx plus my, if you substitute, you will get all 0 values. Okay. So from solving 1, 2, 3, you will get x, y, z values as 0, 0, 0. Okay. So we get, that is x equals to 0. So we'll get one coordinate as 0, 0, 0. That origin you will get. Okay. So next, when you substitute this first one in the fourth one, that is my plus nz. My plus nz means you will get L value here. So whatever the proof is there, I will tell in the next class. So you have another class, I think so. Okay, students, try to practice those other problems. So this proof and the problem on that one we'll see on the next class.
Saturday, ma'am.